In recent videos, you have seen WasmX plugins for Python, JavaScript, and Golang smart contracts. All of these languages become first-class smart contract languages. With WasmX, you can have, even on the same chain, smart contracts written in Solidity, Vyper, Yule, Rust, AssemblyScript, Python, Go, JavaScript. You can have smart contracts that cover the EVM specification, CosmWasm specification, and our own WasmX specification, and have all these contracts collaborate with one another. And all contracts can be used either with Ethereum wallets like MetaMask or Cosmos wallets like Kepler. Today I am going to demo a collaboration between a JavaScript smart contract and a Python smart contract. The JavaScript smart contract will modify the Python contract's state and then also read and return a value from the Python contract state. And all of this is possible due to our meta contracts, which are core smart contracts in WebAssembly that extend the blockchain and are governed and upgraded by consensus. So you can add any language to the blockchain if you add a meta contract for that language. And now the demo. This is a simple storage Python contract. It uses the WasmX SDK to store and load a variable to and from the blockchain. This is a JavaScript contract with two functions, wrap_store and wrap_load. Wrap_store calls another contract's store function, and wrap_load calls another contract's load function. For both wrap_store and wrap_load, you need to provide the address of the contract in bec32 string format. Wrap_store uses the WasmX call method, which can change state in the called contract, and wrap_load uses the WasmX call static method, which can read state from the contract without modifying it. And we also use another WasmX method, which transforms bec32 addresses from string to a more general bytes format needed for the actual WasmX calls. And this is a dApp where you can upload your Python source code, instantiate it as a contract, and then interact with it. And you saw this in previous videos. I have the simple storage Python source code here, and this dApp is connected to a Kepler wallet, which is connected to a local chain that I am running here with WasmX. So we will instantiate this contract with a variable named hello, and this is the instantiate function that we have defined here. When we instantiate the contract, we have two separate transactions. One stores the source code on the chain and assigns it a code ID, and the second will instantiate that source code and make it a smart contract and assign it an address. We can already see the receipt here for the first transaction and the code ID assigned 23, and now the second transaction has been fulfilled and we have our contract address here. We will use this contract address in the JavaScript smart contract. But for now, let's do a query calling the load function with no arguments. So this load function will be called, and we can see the variable that is stored. And that variable is hello. Now we go to our dApp for JavaScript contracts, and I already have the source code for the JavaScript contract written here with the wrap_store and wrap_load functions. So we are going to instantiate this the contract has been instantiated. If we want, we can also take this transaction hash and go to our local explorer and search for that transaction and look at it. But now we go back to our Python contract. We take the address and we will be calling the wrap store function, but we are using the store field here in this object, and we will have two arguments: this contract address and the new variable, let's say goodbye. So now we execute this function. The transaction has finalized. We got our transaction receipt. So if we go back to our Python contract and we load again the variable, we should see goodbye, and this is what we see. And again, we can take this transaction hash and search for it in the local explorer, and we can see the base64 encoded data that we've sent to the JavaScript contract and all the events that were collected here. So we just had a JavaScript contract modify and read the state from a Python smart contract. With WasmX, any contracts can collaborate with one another. Collaboration between JavaScript, Python, Golang, CosmWasm, Rust, AssemblyScript contracts is done through the JSON format, but all of these contracts can also collaborate with EVM contracts that are ABI encoded, with all of the encoding being abstracted away like magic. Future demos will only get better and better. Stay tuned.